Today on How It's Made. Pharmaceutical blister packs. We'll be giving you the pill-popping facts. Deli slicers, a meaty story of cutting-edge technology. Oysters, an appetizing aphrodisiac. And weather vanes, for whatever the weather. Well, as long as it's windy. But first, while the pill bottle isn't yet passé, we're seeing many medications being sold in blister packs. Those cards on which each pill is lined up in a row and encased in a packaging bubble. To take your medication, you simply press the blister and push out the pill through the breakable backing. Blister packaging prevents moisture and air from coming into contact with the medicine. The package is comprised of two layers, typically an aluminium foil sheet called the lidding, and a PVC plastic sheet with rows of blisters. Once the manufacturer designs the packaging format, the engineering department tailor-makes the tools to produce it. This computer-guided mill creates the die which will form the blisters in the PVC sheet. They mount the die on a machine called a thermoformer. As the PVC sheet enters the machine, an oven heats it up, making it soft and malleable. The die then strikes the sheet, imprinting the patterns of circles. A split second after the forming station closes, a blast of air forms the circles into raised blisters. Refrigerated plates then sandwich the sheet, setting the new shape. The pills arrive at the packaging facility in bulk containers. Workers sift off any pill dust that may have formed. They give the pills a preliminary inspection, then load them into a large hopper. The hopper feeds the packaging machine. The blister sheets move through, open side up, so that the pills fall right in. Rotating brushes and paddles disperse the pills into the passing cavities, which are designed to fit one pill per blister. An inspector fills any empty blisters, while a sophisticated vision system detects any broken or chipped pills, flagging them to be rejected later. The blisters enter a seal station, where they're mated with the foil lidding. One side of that lidding is printed beforehand with product information. To make the printing plate, technicians mount a blank rubber mat on a cylinder. As the cylinder revolves, a powerful laser cuts away at the rubber until the information to be printed appears in raised lettering, just like a traditional rubber stamp. They transfer this rubber plate to the packaging line's printing station, where the rubber plate picks up ink and rolls it onto the lidding. The ink dries by the time the lidding reaches the sealing station, where it meets the blister sheet. The next station simultaneously applies pressure and heat. This activates an adhesive on the lidding, heat sealing the sheets together. Then refrigerated plates cool the surface to set the adhesive. Here, a die punches the hole through which the blister pack will lock into a child-proof case. Then, another die punches the individual blister packs apart. Vacuum arms transfer the packs to a single-file conveyor belt, dropping any packs which the vision system identified for rejection. This automated arm sets child-proof cases on a track, moving in parallel to the conveyor that holds the blister packs. Then a loading arm slides a blister pack into each plastic case, mating the hole in the pack to the case's internal lock. Finally, an applicator places an adhesive label bearing all the required information onto each passing case. Random samples undergo a series of quality control checks. In this test for water and air tightness, Technicians submerge the blister pack in blue dye and apply a vacuum. Any dye penetrating the pack would indicate a hole in a blister or a flaw in the seal between the plastic and lidding. Should a particular medication require extra protection, the pack can, for example, be made of light-resistant materials or contain an extra moisture barrier, all to ensure you pop the perfect pill. According to prescription, of course.